Now we have, this is revision lecture for portal method. So calculate axial and shear force in the members GH. So this GH and HI for the frame shown in figure. So now for this we have to consider. So we have first, that is mid height of the column. So we have that as inflection points. So we have mid height of column that are inflection point. So I will show these as inflection points. And then we have this will be G1, this will be H1, then we have this will be I1. So this goes to F1, then we have E1, then we have D1. Then we have mid span of beam that again have inflection point. So this will be G2. And then we have this will be I2. Similarly, we have in FE also, which is F2, and then we have in ED also ED2. So now we have to solve this and consider partly one by one. So now I will consider uppermost half part and we have this part. So now first two assumptions we already considered, that is inflection point. Now we have third assumption, that shear taken by exterior column, that is half of that of interior. So interior we have 2H1 and exterior we have H1, and then we have load here. This is 25 kilonewton. Now here we will apply summation fx equal to 0 and we will get 25 minus h1 minus 2h1 minus h1 equal to 0. And if we solve this, we will get h1, 4h1 equal to 25 and h1 we will have 6.25 kilonewtons. Then we will switch over to the separate part because we have to find shear force and axial force in GH and HI. So we will make separate, that is G point and I point, and then we will solve this. So now you can see this. So I will consider G point separately. So first we have G point. So we have this as G. Now we know force at this G, we have 25 kilonewton. Then this we have calculated, we have 6.25 kilonewton. This is mid height of column, so we have 1.5 meter. This is mid span of beam, so we have this as 2.25 meters. This point we have that is G2, and this point we have that is G1. Now we will have moment about G. So we have only 6.25 and axial force in GF. So this axial force will be downward because 6.25 will develop clockwise. So automatically this, that is FGG1, or I can say better VGG1, and this should develop anti-clockwise. And therefore we will take moment about G20, and then we will have this as 6.25 into 1.5 minus VG1. You can write also, that's also okay. G1 is not required. This joint is G1. So instead of G1, I will write VG1, and that is into 2.25 equal to 0. And if we calculate this value, then we will get this value that is equal to 4.17 kilonewton. Therefore, VG1 equal to 4.17 kilonewton. And plus value means we are going to get assumed direction correct, so downward. And now by using summation fx equal to 0 and summation fy equal to 0, I will get value of G2. This Vg1 I got it as 4.17, which is downward. So automatically at G2 I have this will be upward with 4.17 kilonewton. Now as 25 is towards right, 6.25 is towards the left. So we will get this value that is equal to 25 minus 6.25, and we will get this value that is equal to 18.75 kilonewton. And now we have, therefore, axial force in GH is 18.75 kilonewton, and shear force for GH is 4.17 kilonewton. Now we will go to HI, and now instead of considering H, I will consider I. So what we will get in that case now? So we have considered I. So we have this as I, we have this distance 1.5 meters. This is 2.25 meters. Now we know this value, we have 6.25 kilonewtons. And we are going to find out remaining three values. So now how we will go for remaining three values? Then we can have this summation fx0. So I will get this value, that is 6.25 kilonewtons. Now I will take, we have this joint, that is joint we have I2. And this joint I have I1. Now I will take moment about I2. Now you can see, if due to 6.25 moment is clockwise, then due to vertical force it should develop anti-clockwise, and we have this as Vi1. And then we will have moment about I20. So we have 6.25 into 1.5 minus, sorry, now this distance is not 2.5 meters. Now you can see we have this as 6 meter, and we have center of this. So this distance becomes your 3 meters, and minus Vi1 into 3, and that is equal to 0. And from this I will get Vi1 that is equal to, we have value of Vi1, we have 3.125. So I can write 3.13 kilometers. And now apply summation Fy0. So automatically I will get, this will be downward and 3.13 kilometers. This is upward. So summation Fy0. So Vi1 upward. So Vi2 we should get downward. And then we can write axial force in HI, axial force in HI, and that is equal to 6.25 kilonewtons. 6.25 kilonewtons, and shear force in HI, and that is equal to 3.13 kilometers. Now, if you have to draw bending moment diagram, so you can see for GH. So now for GH, we have this as 4.17. This is shear force. So 4.17. So moment about G2. So equal to 4.17 into 2.25. So we have this value 4.17 into 2.25, 9.38 kilonewton meter. Now you can see how we will get this moment. So due to 4.17, this moment is anti-clockwise, and to balance it, we have clockwise 9.38. So it will take beam down. So I will have this diagram in this fashion. And I have this value 9.38. So 9.38. This is bending moment diagram for GH. 9.38. Now if I have to plot for HI, now we have 3.13. So I will consider this about H. So we will have moment about I, sorry. And then we have 3.13 into 3. So equal to 3.13 into 3. So this is 3.13, this is 3. And this will be anti-clockwise. To balance it, we have clockwise, which is at I. And it will take up, what will be value? Will be 9.39 kilonewton meter, and then we have this value in this fashion. Same we have bending moment diagram, that is on tension side 9.39 kilonewton meter. So you may have question that plot bending moment diagram, and in that case you should be in position to plot it. So this is first problem where we have this BMD. Now we will switch over to the second problem, which is we have axial and shear force in member JK only. But now here we have again four columns. So I will directly go fast. We have this will be inflection point, that is at mid height of column. I will not give names to all, but we know we have this four here. So I can write it as I1. So okay, I will give name J1, K1, L1. Bottom we need not require to mention it. Then I have this as I2. Then you can have this. Now you have to decide J2 or K2. And then we have this as L2. So now again we will consider only upper half portion, and then we will be with third assumption, and that third assumption says my shear taken by interior column, that is equal to twice that of exterior column. So this is twice H1. This also we have 2 H1, and then we have this as H1. And force that is acting at I, we have this as 18 kilonewton. And then we have, now I can write it minus H1 minus 2H1 minus 2H1 minus H1 plus 18 equal to 0. And therefore 2 to 4 to 6, 6H1 equal to 18. And therefore we have H1 is equal to 3 kilonewtons. Now we have to find force, axial and force for JK. So now we will switch over, we will consider first I joint. So if I will consider joint I, then we know we have this force that is 3 kilonewtons. We have this distance 2.5 meters. We have this distance 2 meters. We have this, that is force that is given 18 kilonewton. So this joint I have I2, this is I, and this is I1. Now same concept, 3 kilonewton will develop clockwise. So whatever reaction we are going to consider, that is at I1, and that we are going to consider it as downward, will develop anti-clockwise moment. So we have this will be VI1, and then we have moment about I20, and we have 3 into 2 minus Vi1 into 2.5, and that is equal to 0. And therefore I will get Vi1, I will get that is equal to 2.4 kilonewtons. Now I can have direct values at I2. I will apply Fx equal to 0. So we have 3 kilonewton towards left, 18 towards right. So I require 18 minus 3, and this will gives me 15 kilonewton. Now Vi1 downward value 2.4 kilonewton. So automatically I2, it will go upward 2.4 kilonewtons. Now I will consider joint J, and when we will consider joint J, and then we will get whatever forces we require. So we will have this joint J. So while considering joint J, so this we have, that is I2, and we have equal and opposite forces. So we have at I2 we have 15 kilonewton towards the left. So I will get this 15 towards right. And then we have 2.4 upward. Here I will get 2.4 kilonewton downward. Now already we have calculated this value. We have 2H1 and this we have 6 kilonewtons. And we are interested to find the remaining values. Now if we will see carefully, then we are going to be with summation Fx equal to 0 and we will have this force. That is this we have considered actually as J2. So we have this point as J2 and then we have 15 minus 6 and we will get it as 9 kilonewton. Now we will take moment about J2. We will consider this force. Now we have this joint that is this is J joint. So automatically we have this will be J1. And then we have this will be Vj1. Now I will take moment about J2 equal to 0. Then we have minus 2.4. Now we have this distance as 2.5 meters. We have this distance as 3 meters. So we have 2.4 into 5.5. Then due to 6 we have plus 6 into, now we have vertical distance 2 meters. So into 2 minus Vj1 into 3 equal to 0. And then we will get this value of Vj1 and that value we got as 0.4 kilonewtons. 0.4 kilonewtons. And now I have this Vj1 plus means assumed direction is correct. So 0.4 kilonewtons. Now we will apply summation Fy0. This is 2.4 downward, 0.4 upward. So I will get this value that is 2 kilonewtons. And therefore now we have therefore axial force in Jk. So just we have to find in Jk. And therefore we have axial force in Jk in member Jk and that is equal to we have 9 kilonewtons and shear force in Jk, shear force in member Jk and that is equal to 2 kilonewtons. So we have these are the answers of these questions. Now bending moment diagram already I have explained in last example. You can plot it bending moment diagram that is on tension side. So this is all about your two questions which are related with your portal method that is given from your question bank. And now we will stop here only. So thank you.